Looks like it's recording. Okay, so a couple thoughts about the test before we talk about this. So your homework is due, I'll collect it the day of the test. So before the test, you'll fill out that front sheet. Is everything done? And how well did you keep up? And did you pay attention during class and use class time wisely? So that's the front sheet. You'll fill it out. And then when you hand it in, I'll double check to see if I agree with how you scored it. And occasionally I'll take off a couple points if you were a little generous, or add a couple points if you were a little too harsh on yourself. And then you'll get the test back the following class day after you take it, which isn't for a while for you guys, right? Because we have the test Thursday, Fridays even. We have Monday off. Tuesday is odd. I'd see you guys on Tuesday next week. Does that sound right? So you get it back on Tuesday. You can make test corrections. When you make test corrections, you have to find your mistake and explain what you did wrong, and have the correct worked out solution. If you have both of those things, you can get half of the points back on the problem you missed. Most questions on a test are worth 2 points. You get 1 out of 2 if you look like you were on the right track, kind of in the ballpark. 0 out of 2 if you looked like you had no idea what was going on and just scribbled some mumbo jumbo down. So 0 out of 2 is not on the right track. 1 out of 2 is on the right track. Maybe just a careless mistake. Okay, so you can get half the points back. The test corrections are due about a week after I hand the test back. So when it's kind of fresh in your mind, I want you to do the test corrections, not wait like a couple months to do them. Most tests are no calculator. That's true for this one. So there was a few things I wanted to do on your calculator, but they will not be on the test. What else? Is there anything? Not that I could think of. Test next class, handing your homework, no calculator. I think that's about it. Okay, so if we're gonna correct, what worksheet is this? 1F, domain and range. Okay, I think this looks like kind of like your worksheet. This is an old answer key. There might be some things I wanted to change, and I was gonna type one up on your sheet, but evidently I forgot. I got started, but it's, looks terrible. Okay. So function no. This is one way to write the domain, but after I started writing it like this, I realized, well, most calculus books, there's a shorter way to write it, and most advanced textbooks use that way. So I got to, you might as well just get used to it if you want now, because that's what you're going to learn in pre-calc. So an alternate way of writing this would be 3, 7. It's like a shortcut. The alternate way of writing this would be 1, 5. Bracket means included. Parenthesis would be not included. It's like -2, 3. And this one would be -1, bracket, 4. Questions so far? Domain. You could write -infinity, infinity. If you like that. The standard is to put parentheses around infinity because infinity is a concept, not a number. So you don't include infinity as the stopping point. Infinity isn't a stopping point, it's a concept. Okay, or you can just write all real numbers if you like. Questions so far? Anyone? Okay. Oh no. It's a long way to go to get an eraser. All right. Let's see what else we got. How about these interesting problems? What happened? Function, yes. Domain, all real numbers. Range, -5 to infinity. This is the alternate notation that's quicker and used in more advanced textbooks. You can use either notation. Function no. Oh, it should have asked if it was 1 to 1. Next year it will. It should have asked if it's 1-to-1. Okay. If it's a function, every input has only one output, passes the vertical line test. So function, yes. Is it 1-to-1? Are all the outputs different? No. That will be on the test. It should have been on this worksheet. It will be next year. Not that you would care, but if it's any consolation, every year the worksheets get better, more thorough, longer, harder, more interesting. Okay. Function, no. Domain, yes, it still has a domain. The domain goes from -infinity to 1. You could write it like this. -infinity, comma 1. The range, -infinity to infinity, you could write all real numbers if you'd like. I'll accept any notation as long as your domain is correct. Okay? Is it a function? No. Is it 1-to-1? That question doesn't make sense. It's not applicable. If it's not a dog, you can't check if it's a chihuahua. So this question would be not applicable or applicable. How do you pronounce that? Not applicable. Okay. Function, yes. Domain, all real numbers. Range, -infinity to 2. Including 2. No. Yes. It includes 2. -infinity to 2. 1-to-1? 1-to-1? No. Any questions on those? Anyone? Anyone? Did you get those right? Uh-oh. You have it somewhere? You haven't lost it. Just not with you. I might have an extra one if you want to do the review. Okay. So you're okay on those? All right. What other problems? How about these interesting problems? These are just points. You can't connect them. The domain is just the inputs. What inputs have outputs? Those. Those are the inputs that have outputs. Can you connect them and write this like -1, like -4 to -1? Can you write it like that instead? No, because that would imply there's things between -1 and -2, like -1.5. Is there an output at -1.5? Not if you interpret this literally, which is what you're supposed to do. So what is the range? Just those numbers. The range is just the y values. You can't connect them. You can't write it with parentheses because parentheses would imply it's connected. But you can't do that. Questions about those? Can you connect these? So the ordered pairs are just the points, like 1, 2. 1, 2 is an ordered pair. It's a point. Ordered pairs are another word for points. So 1, 2, 2, 5, 2, -1. What's the domain? Okay, what inputs have outputs? Is it like 1, 2, and 3 or something like that? What is the range? What are all of the outputs? Is it a function? No. Does every input, like 2, have only one output? No, look. At 2, it fails the vertical line test. Any questions? Anyone? Okay. All right. These? Any questions on these? Of the previous ones? Okay. I'll go back in a second. So since these are up, any questions on these? So you know the alternate way to write this? You could put bracket -2 comma 4, 1 comma 4, like that. Any questions on those? Does it matter if you write x2 or 2x? Does it matter? Well, I mean, these are both, these mean the same thing. This means x times 2 and this means x times 2. This just looks goofy. So does it matter? Well, I guess technically these are the same thing. So if this was the answer, would I count this right? Well, yeah, you just wrote it funny. So what I'm trying to say is I will give you credit if you write it funny. It's supposed to be written smallest to largest. If you flip-flop that, it's still right. It just looks a little funny. This looks really funny. I mean, you'd never write that, right? But it's the same kind of concept. There's a standard way of writing things in mathematics that I want you to get used to. If you have the right answer but have written it a little funny, I'll still give you credit, but I would like you to get used to the common way of writing things. So when you get to college, people don't laugh at you. If you wrote that in college, people would think you're pretty out there. We don't want that to happen, do we? Okay. So any question on those? Then we'll go back to the previous page. Yes?
I'm not quite sure how you figure out which one is a function. And which one.
Does every input have only one output? That's the question. Does this input have only one output? Yeah. If you move this vertical line around, the vertical line is like the input. Does every input have only one output? Yes. Here, yes. Here, no. Does this input have only one output?
Oh,
Yeah. Okay, now we'll go back to the previous page. Yes, question on one of these?
Domain is horizontal, right?
Yes, domain are the inputs that have outputs. That is accurate.
So wouldn't the range be 1, 2, 3 instead of domain?
So the domain, what inputs have outputs? Does this one? Yes, it does. Does this one? Yep, it does. Does this one? Yep, it does. These are the inputs that have outputs.
Oh, good. Oh, yeah.
Did it dawn on you? Okay, good. All right. That was 1F. So the rest of the period is essentially time to study for your test. Now, more specifically, I was going to try a few problems from the review. During work time, it would also be a good plan to look back at some of your worksheets and see if there was something that wasn't done that you got stuck on, but never had time to ask. There should be time to ask today in class, individually. Before we get to individual work time, let's look at the review. Okay. See if I can find a copy of the review. Calculus, that looks interesting. It actually is interesting. But you have to wait a couple years to take it. This is Enriched Algebra 2. One G, the review. Okay, I've located the review. Okay, this test, the whole thing will be no calculator. If that wasn't clear already. So like problems like this, the idea is you're trying to figure out how to do them without a calculator, not how to punch them into your calculator. So the entire test is no calculator. Okay. So this unit, we've talked about, we've reviewed our order of operations, we've reviewed fractions. This is background material. The unit was about functions. We talked about what's a function, what's not a function. Now, for this particular worksheet, it says you will need to graph A, B, and H using a graphing calculator. That explanation makes more sense down here. To find the domain and range, that's when you need to graph A, B, and H. You can see if it's a function without the graph. So on the test, so I do want you to be able to use your graphing calculator, except on the test itself, the graph will be provided because it's just simpler that you don't use a calculator ever rather than just on like one problem. So here's where you graph A, B, and H for the domain and range. Graph A, B, and H. Okay, so you should be able to use your graphing calculator, but it's not part of the test that you can. Okay, I think there was a tricky one. I believe it was B was a little tricky. So I don't know if you tried it or not, that's irrelevant. If you tried B, see if you got it right. If you didn't try it, pay attention. Okay. Let's try to figure out if B is a function. Does every input, oh, but the graph would have helped you here too. It just makes the problem simpler. So maybe I'll leave those directions up there. It's fine. Okay. Is it a function? That's not too hard to figure out without a graph. Okay, function. Question. All right. Now, most formulas are functions. There's a couple formulas that aren't, that look a little wacky. Okay, does every input have one output? It's not that hard to figure out. Just plug 2 in. If you plug 2 into the formula, do you only get one number? Well, of course. What if you plug in -2? Do you only get one number? Of course. What numbers do you get? I don't know. It doesn't really matter. Of course you only get one number. Like, is the absolute value of -2 only one thing? Yeah, it's +2. Is it a function? Of course it is. Is it 1-to-1? Ooh, that's trickier. Now the graph is going to help us with that. We could probably figure out without a graph. Do you think we could figure out without a graph? Okay. So you think the answer is no? Okay, I'll write no down, but if you think it's no, you need to give a counter example. Are you ready for the counter example? So your counter example, you're going to prove it's no. Your counter example is, okay, what do you want to plug in? What else do you want to plug in? Ooh, is this really a counterexample? So what's the question? Does every input have only one output? Yes. What's the question here? Are all of the outputs different? You think the answer is no. Are they all different? Let's try this. What's 1 over the absolute value of 2? 1/2. What's the absolute value of -2? What's 1 over 2? 1/2. Oh, holy cow, we got the same thing. It is no. Are all the outputs different? No, look. That wasn't that tricky. Now, let's look at the graph, which on the test would be provided, but you're supposed to be able to use your graphing calculator. So, if you go to your graphing calculator and hit skip for now, skip anyway. Okay, you can hit y equals, and then your graphs pop up. Well, these aren't your graphs. These are the spot for your equations. So hit y equals, and then hit 1 divided by, did you want to get yours out? You should be able to use your graph. Is that your graphing calculator?
I
Or are you
already did
just,
it.
what?
I already did it. Before you helped me with it last class.
Then why is your phone up? Were you using your graphing calculator on your phone?
Yeah.
I doubt it. Were you really?
No, look.
No, on your phone. Were you really using your graphing calculator? You don't even know how to get in here.
I know.
You're locked out now.
Okay, well, don't say that. You shouldn't.
Where's absolute value on this silly thing? It's hiding from you. And I'm not kidding. Where's the absolute value button? It's not there. It's hiding from you. You have to find it. It's under math. And then num. Math num.
Wait, how are you doing that? I'm so confused.
I hit the math button because I couldn't find the absolute value button on the screen. I hit the math button, and then I went over to num, and then there it is. I hit math, num, and then I'm going to select absolute value. Look, there's the absolute value symbols. I can't believe it. Now you have to find your variable button. Your variable button is right there. Depending on what mode you're in, like X is regular algebra, T is like if you're doing something else, theta is like trigonometry, and N is if you're doing like something else. So depending on what math course you're in, you'd use this variable button. So for us, it's just X. Now I'll hit the graph button, and there is our graph. Ooh, interesting. You remember what this thingy is called? This horizontal line that the graph comes close to, but doesn't, can you see it not quite touching it? It's called an asymptote. Is there another asymptote?
Wait, what I missed?
This is an asymptote. Is there another one? Look, what's the graph doing here? It looks like it's coming close to the y-axis, but not quite touching it. That's another asymptote. Holy cow, there's two of them. You see them? Okay. So that's the graph. So if that's the graph for B, what is the domain and range? Okay, maybe I'll go back to it for a second. It was awfully interesting. Okay, what's the domain? Does this input have an output? Yep, it's part of the domain. Does that input have an output? Yep. Does every input have an output? No. What about that one? What about 0? Is there an output at 0? No, because the graph comes close to the y-axis but doesn't quite touch it. So what's the output at 0? There isn't one. Does everything else have an output? Yes. So what's the domain? Everything except 0. Right? Clearly that's the domain, right? Look. The domain is everything except 0. So down here for 8b, the domain is from negative infinity to 0 and 0 to infinity. And we're not including 0, so it's parentheses. So that would be a technically correct mathematical notation for the concept, everything except 0. Here's another way to write it. All real numbers, all except this. This isn't as technically correct, but if you forget the technical notation, I would accept something like this. Or you could write all real numbers except 0. Okay, what's the range? Okay, what are the range of outputs? Can you get like a bazillion as an output? If you get close enough to 0, could you get a bazillion? Yeah. That's part of the range. Can you get like 1?
Yeah.
How about 0?
Would be 0 in parentheses.
Because this comes close to, but doesn't quite touch 0. Can you get 0? No. Can you get right up to it? Yes. So it would be the answer. The range starts at 0 and goes to where? Infinity. But does it include 0 in the range?
No.
So it's a parenthesis. Or if you don't like that notation, you could say y is greater than 0. It means the same thing. That was an interesting one. Goofed up. Any others you want to talk about in this area? Other than no? You sure? Any of these bad boys down in here? Any doozies? Down in here? Is it hard to plug in a number? Is it hard to plug in a letter? No? Oh, so it's
No,
trickier.
The E one, I got
Which one?
the E,
E?
the one you were pointing at.
E. This one.
Yeah.
Finding g of x minus 2?
Yeah.
Let's
I got
see what it looks like. Okay, so you're supposed to plug x minus 2 into the g formula, right there. So you're supposed to plug x minus 2 into the g formula. And then you're supposed to simplify. So that would be 2. So g of x minus 2 equals 2 times x minus 2 squared minus 1. And then they want us to FOIL this out and combine like terms. They think that looks better.
Can you move over a little bit so I can see it?
Right, what?
Can you move over?
Oh, yeah, of course. I can even go over to that side of the board. Okay, so how do you FOIL this out and make it look better? What do you have to do first? I would multiply x minus 2 by x minus 2. Order of operations. Exponents come first. But you can't distribute the exponent. You have to FOIL it out the long way. And then, these smudgy things are 2's. And then, after I FOIL this out, I would multiply that whole thing by 2, and then I would subtract 1. Okay. So, can you do x minus 2 times x minus 2 sort of quickly and accurately? X times x. X squared. X times negative 2. Negative 2x. Another x times negative 2. Another negative 2x. You always combine your mental terms. What's negative 2x and negative 2x? Negative 4x. And then negative 2 times negative 2? Positive 4. And if you want to show more work than this, you can. But I wouldn't recommend showing less work because I think you'll make a mistake. Now, distribute the 2. 2x squared minus 8x plus 8 minus 1. 8 minus 1 is just 7. Okay. Now, on the test, I said I would write this in the clearer notation to one of my classes. I don't know if I promised you guys that, but this means f of x plus g of x. Someone said, well, can you just write it like that on the test because it's a lot clearer. F of x plus g of x. And I said, sure. So on the test, these will be written f of x minus g of x, which is much clearer. So this would be written f of 2 plus g of 2. This would be written f of x times g of x. Okay? So it'll be written in the clearer notation on the test. So it's less confusing. Okay, any questions here on anything? Yes, this one? Really? The answer key could be wrong. It's always a possibility. Let's try. For C, f of x times g of x. What's C? What's f of x? 2x squared minus 3. 2x squared minus 3. What's g of x? 3x minus 1. So now what does it want us to do? When we multiply these, we have to FOIL it out. What's 2x squared times 3x? 6x to the third. What's 2x squared times negative 1? Negative 2x squared. What's negative 3 times negative 3x? Negative 9x. What's negative 3 times negative 1? Now we combine like terms. But weirdly in this problem there aren't any. Usually there are. Is that the answer I have in the answer key? Good. Okay. Do you remember how to, there's only 12 problems? Oh, but I suppose 11 does have like 6 parts. I was thinking 12 problems, that's awfully short. I like to make the reviews kind of longish and definitely thorough. So there's a bunch of other stuff that you have to study. Is there a bunch of other stuff that you have to study that's not on the review? I don't think so. Did you do a bunch of other stuff? I don't think so. So maybe you try to figure out our calculators, but that's not going to be on the test. What else did we do? Not much. This is pretty much it, isn't it? So the reviews are intended to be thorough, not necessarily enough practice. Like, are these 3 problems enough practice? I don't know. That's up to you to figure out. But this concept will definitely be on the test, and there's a few practice problems. If you guys think you need more practice problems, maybe go back and try some problems again from the worksheet, stuff like that. So what should you try to figure out first? You should see if it's a what? Product, because that's easier. And then if it's not a product, it has to be a, because that's only 2 choices. Are any of these products? That one? That's the product. That's easier to figure out. Are the other 2 products? No, that means they have to be compositions. Is there more than one correct answer for a composition? Yes, but there's usually one clearer answer. So let's try it. I don't think it really matters. They're kind of similar. Let's try A. So if we use the notation f of g of x, we have to identify the functions. Identify the 2 functions. In a composition, what do we call the functions? This is referred to as the inner, that's the outer. If you want to use different letters, that's acceptable, but I don't know why you would, because this is what everybody else uses. Okay. Make a wild guess at what the inner formula might be. You think it's 2x plus 1? Well, what would the outer formula be? So where there's a 2x plus 1, just put an x there, and then write the outer formula. What's the outer formula? Okay, now, if you put this right there in that formula, do you get that? Does it work? So then I would accept it as a correct answer. Are there other correct answers? Maybe, but this is the best one. It works. That's the best answer. Okay, I'm going to stop recording. Good luck, everybody, during work time. Stop recording.